Hello everybody, in this video I will go through a solution to a problem that's very similar on your activity worksheet, and this problem actually covers most of the basic concepts of probability. Okay, let's see what we have here. We have a large cooler that contains different flavors of drinks, and we have 6 lemonade, 8 Sprite, 15 Coke, and 7 root beer. We're asked to compute these probabilities of these different events. The first one says, what is the probability that you get 2 cans of Sprite? So I'm asked to find the following. Probability that I get Sprite on the first try and Sprite on the second. Okay, so what do we do here? And means that I will be using multiplication rule. And now I need to think this through. If I take my first drink without looking, and I want to know what the probability of that being Sprite, I know that there is 8 Sprite total in the cooler, and there are total 36 drinks. So the chance of getting Sprite on the first try is 8 out of 36. Okay? Now, what is the chance that I get Sprite on the second try? Now remember, we're doing this without replacement. So how many drinks are there left in the cooler? Well, now there's 35 drinks left because I just picked one out. And out of those, 7 Sprites. Okay? So now, this is the probability of the following event, that I get Sprite on the first try, followed by Sprite on the second one. Okay, once you compute this, let's go ahead and round all of our answers to 3 decimal places, so you should get 0.44. Okay, let's see. Let's take a look at this example here. What is the probability that I do not get 2 cans of Coke? This is a perfect problem to use the complement rule. Okay, instead of computing it directly, probability of not getting 2 Cokes, I'm going to use 1 minus the complement of this event, which is getting 2 Cokes, so probability of getting 2 Cokes. Okay, and how do we compute the probability of getting 2 Cokes? Just like we did in part A for Sprite, so this one would be 1 minus, and let's see how many Cokes we had there, 15. Okay, so if I pick Coke on the first try, there's 15 of them, 36 drinks total, times 14 Cokes left, 35 drinks total left in the cooler. Okay, so this number right here represents the probability of getting 2 Cokes. Once you compute this, you should get 0.833. Okay, so that's how we do this. Let's take a look at the next one. What is the probability that you get either 2 root beer or 2 lemonade? Alright, or means what? Well, we should be using general addition rule. Now the question is, are these events disjoint? Are they mutually exclusive? If they are, that's nice, because we do not have to worry about the subtraction of the intersection, right? So just to remind you, the general addition rule looks like what? We have P, A, or B, probability of getting A plus probability of getting B minus the probability of A and B, right? That's your general addition rule. But if our events are getting 2 root beer or 2 lemonade, they do not have anything in common. You either get 2 root beer or 2 lemonade. So we don't have to worry about this part right here. Okay? So what is the probability that you get either 2 root beer or 2 lemonade? Well, 2 root beer or 2 lemonade. Okay? Then I just need to find the probability of getting 2 root beer and add it to the probability of getting 2 lemonades. Okay? Now these two are done just like we did it for part A for Sprite, right? So what do we get here? 2 root beer. 7 root beer to begin with. Once you pick one out, there's 6 left and 35 cans left total. Okay, that's the probability of getting 2 root beer. And for the lemonade, what do we have? Let's see, how many are there? Okay, 6 lemonade. So 6 lemonade out of 36. That's the probability of getting lemonade on the first try, times 5 out of 35. Okay, once you compute this, you should get approximately 0.57. Alright. Okay, so here's an example where we use the general addition rule, or we'll tell you that's the rule that you'll be using. And when you have and, okay, so 2 cans, Sprite and Sprite, that's your multiplication rule. That's the connection that you should establish so far. Okay, what is the probability that I get 1 can of Coke and 1 can of Sprite? Now this one is a little tricky, because what you need to realize here that they're not telling you the order in which they want you to get Coke and Sprite. They just say, okay, 1 can of Coke and 1 can of Sprite. So we can have 2 different situations. The first one is that you get Coke on the first try, followed by Sprite. That's one way to get it. Or you can get Sprite on the first try and then Coke on the second. Okay, so how do we compute these probabilities? So for the first one, let's see, we have 15 Cokes out of 36 cans times, now there's still 8 Sprite left and 35 cans left in the cooler. Okay, that's the first situation. For the second one, it is 8 out of 36 to get the Sprite first, and then 15 out of 35 to get Coke on the second try. And notice that you actually get the same number. So what you can just do, you can just find one of them and double it. So you should get 0.095 here, 0.095 here. If you add them all up, this would be the probability of getting 1 Coke, 1 Sprite, regardless of the order, and your answer should be 0.190. Okay, so that one is a little tricky, because usually what I see students is not realizing that you can have 2 different situations that describe this event. Okay, but the probabilities are the same, so you can compute one of them and just double it. Okay, let's see. The last part here, what is it asking us to do? What is the probability that I get 2 drinks of the same type? Okay, what does that mean? So that means we would like to get either 2 lemonade, 2 Sprite, 2 Coke, or 2 root beer. Alright, so this one is really just combining all those 4 events. So same type, right? So let's say what if I get 2 of the same type? So it's the probability of getting 2 lemonade, or 2 Sprite, or 2 Coke, or probability of getting 2 root beer. Okay, that's all of them. So all of these events are mutually exclusive. Okay, we do not have to worry about the intersection. You either get 2 lemonade, or 2 Sprite, or 2 Cokes, or 2 root beer. Okay, so how do we do this? So for lemonade, we have this expression here, 8 times 7 for Sprite. The denominator is going to be the same for all of these fractions. Okay, so 36 times 35 here for Coke, and root beer we got 7 times 6, 36 out of 35. Okay, and what I would recommend doing, if you guys have to do a problem like this, don't round these numbers here. Actually plug them in your calculator as is, and then you get the answer. So you should get about 268. That's the probability that if you reach into the cooler without looking, you get 2 drinks of the same flavor. Okay, so let's review real quick what rules we've done so far in here. So here we did what? Multiplication rule, but not only that, these 2 events are dependent, so we used conditional probability. Okay, condition on what? Well, the condition was that the first one was already Sprite. That changed the probability of getting Sprite again. So here we used multiplication rule and conditional probability. Let's take a look at the second one. Here we used the rule of complement. Okay, it is easier to compute probability of not getting 2 Cokes by using complements, because this part right here is easy to calculate. Okay, let's see, in part C we used general addition rule. Whenever you see or, that's when you use the addition rule. Okay, these are mutually exclusive events, so we don't have to worry about the subtraction here. Okay, here again we use multiplication rule, but also we needed to realize that there are 2 situations that will describe this event, right? Coke first, second Sprite. Sprite first, Coke second. And here we used, we used multiplication rule and we used addition rule for mutually exclusive events. Okay. Thank you for watching.